naturalists in Banff, and this presentation will be a similar format with a number of updates on what we've learned about this intriguing species over the last year. And I really hope you'll come away understanding the awe that Dawson must have felt when he referred to black swifts in 1915 as a bird of the high mountains. So I've included a lot of content in this presentation with the intention of giving you an overview of black swift ecology, how specialized they are, and provide some understanding and context for why it's so challenging to monitor them. I'll also touch on the array of tools we're implementing or piloting to better understand and protect black swifts in their habitat. So it's a lot to share in this presentation. And if we get to any questions at the end that I can't get to or I don't know, then feel free to contact me after the presentation. Okay, so let's just start with what black swifts are and what they're not. So who are these black swifts that we're referring to? So swifts are in the family Apotidae, and they're characterized as highly aerial birds. And although they have a similar appearance to swallows, they are only superficially related to them and are not a passerine. They're more closely related to hummingbirds than swallows. And black swifts are the largest of 4 swift species in North America, which also includes the chimney bows and white-throated, and they're at about 18 centimeters and 45 grams. They're the only species to have an all black or sooty appearance, and over most of its range, it's going to be the only black swift with a notched tail. So the borealis subspecies that we'll be talking about tonight, also known as the northern black swift, breeds from Mexico through to Alaska, and then they migrate down to South America to the state of Amazonas in Brazil. And the northern black swift is considered one of 3 subspecies of black swifts, though subspeciation is not confirmed through genetic analysis. So let's look at identifying a black swift. So black swifts, like I mentioned, are black, mostly black, and have a frosty white brow, and then they have some variable white edging on belly feathers, and they're which is more prominent in the females. And then the feathers on the head tend to be lighter sooty or brown. There's little sexual dimorphism, so males and females vary little in appearance, with males having the greater notched tail, and then the females have more white on the belly feathers. And then nestlings have similar white edging with additional edging on the wingtips. And black swifts have what's called a pamprodactyl toe configuration, which means all 4 of their toes are oriented forward for gripping and clinging rocky vertical surfaces. So here's a photo from a local photographer in Banff and park staff member Amar Othwal. And here you can see the white edging to most of the flight feathers, which is absent in the adults. So let's look at breeding distribution. Canada has the largest concentration of breeding black swifts in North America at about 86 to 89%, and that's based on the Partners in Flight database, with most of that occurring in BC and only a really small percentage occurring in Alberta, so less than 1%. Black swifts are present in all the mountain national parks, including Jasper, Banff, Kootenay, Yoho, Waterton, and Mount Revelstoke Glacier, although locations of nesting sites in a lot of these parks is still unknown. Northern black swifts are found in several US states, which I'll elaborate on in a minute. And then Canadian population estimates range quite a bit, anywhere between 15,000 to 80,000 birds. So soon you'll understand why this estimate is so imprecise. And then the nesting season begins in late May with arrival of birds from South America and ends by early to mid-September when the chick has fledged. So taking a look at this eBird range map, it gives you a good visual representation of where the greatest concentration of birds are being recorded. You can see the heavy concentration of observation records predominantly in Western BC, including Vancouver Island, and distinctly absent from Haida Gwaii, so far anyways, although more efforts being invested in conducting an inventory there to see if in fact they may be breeding there. In Alberta, you can see that we're at the eastern edge of their breeding range in Canada. And in the US, the biggest concentrations are found in Washington State, Colorado, Idaho, California, and then as well as Oregon, Montana, Utah, New Mexico, Wyoming, and Alaska, although nesting sites in Alaska aren't known at this time. So in Mexico, there is some overlap between the Borealis subspecies and the costarricensis subspecies. The costarricensis subspecies is mostly found in Costa Rica, and the Niger subspecies is found in Cuba and the West Indies. So flight and foraging. In this photo of a bird flying above Marble Canyon in Kootenai National Park, you can see the long pointed wings and the slight notch in the tail. They're extremely efficient flyers and one of the most aerodynamically efficient bird species. So the notched tail reduces a lot of drag, and they've got a lift to drag ratio of 13:1, which means they've got a lot of lift and very little aerodynamic drag as they move through the air. And black swifts spend most of their lives on the wing, foraging for flying insects, also called aerial plankton, with flying ants being their main source of prey, but they will feed on a variety of other insect species. Stomach content studies have found like up to 67 species in total. They'll spend their days seeking out large patches or blooms of airborne insects and use their wide bill to scoop up their prey. And in Colorado, black swifts have been recorded flying as high as 4,300 meters. And I've seen them locally above Marble Canyon, foraging at about 2,000 meters. And that's right after leaving the canyon first thing in the morning at dawn. And they're likely progressively flying at higher altitudes throughout the day. So black swifts will forage, progressively farther from the nest throughout the day and can travel well over 100 kilometers in a day. And then in 2012, it was first discovered that black swifts fly to South America in the winter, and that's based on geolocators placed on a few birds from Colorado. 3 birds were recaptured, and data indicated wintering grounds in Western Brazil. So on that note, let's go on to talk about movement ecology a little bit. So in 2017 and 2019, researchers in Colorado again tagged birds, but this time with GPS and wing activity devices, which are called the accelerometers. And the Canadian Wildlife Service provided some of those GPS devices. So the results of the recovered tags indicate that black swifts are in fact aerial roosters. So that means in the winter, they are largely in the air 24 hours a day throughout that whole winter season, which is a really exciting find. Even more intriguing, I really like this, is the fact that during a full moon, black swifts will fly at higher elevations. So it's not totally known why, but one theory is that it's to avoid the greater risk of predation under the brightness of a full moon. So aerial roosting is known to occur in other swift species, including common swifts, alpine swifts, and pallid swifts. So in a sense, this isn't surprising, but to actually discover this behavior for the first time in a species would have been pretty exciting. And researchers were also able to gain some understanding of how swifts are using available habitat around their nesting sites. So data shows a preference for higher elevations and along rivers, which is likely related to insect distribution. Foraging movements on average were 160 kilometers a day in the month of August, which is a long way to fly for food every day. And then a driver of those foraging patterns seems to be the landscape features and characteristics surrounding the nesting sites. So for example, snow melt occurring later in the summer coincides with subalpine insect blooms, which attracts black swifts to forage at higher elevation bands. And then birds will also spend time foraging in longer river valleys with greater wet habitat to support greater abundance and diversity of insects. So now we'll move on to what we're most focused on for our monitoring in Banff National Park, which is the black swift's nesting behavior and requirements. Essentially, their range is limited by where they nest along canyons and beside waterfalls and occasionally in caves. They use pockets or ledges found along steep walls and cliffs, and they only lay 1 egg per season. So 1 egg, 1 clutch. The nest is a simple mossy cup, and it's reused, so it'll often continue to grow. And that egg is usually laid by the end of June, and the chick doesn't fledge well into September. So chicks are attended to pretty infrequently and may spend up to 12 hours alone before being fed, especially as the chick gets older. And both adults share responsibility during all phases of nesting. So black swifts are generally do return to the same sites. They've got high site fidelity year after year, and they'll reuse those nests. So let's look at the basic habitat requirements. So black swift requirements are broken into 6 key features, and these indicate what true habitat specialists they are. So to maintain a consistent microclimate around the nest, water flow needs to be consistent throughout the season, and nests need to remain mostly shaded. Since the chick is left alone for so long, having a cool, consistent environment can help keep metabolic rate lower to endure those long periods without provisioning. And there really has to be suitable ledges or pockets for nests, moss nearby for building and repairing the nests, as well as steep terrain and minimal obstructions, so the birds can easily fly in and out of the nest sites and have protection from predators. So nest ledges or niches appear to be a limiting factor in site suitability. You can have all those other requirements present, but if there's no pockets or niches or ledges to build a nest on, you're out of luck. And I've seen that repeatedly doing habitat surveys, that we can have a really great site, but there's really no pockets for a nest, so they're just not suitable. So let's look at how black swifts are doing. The Committee on the Status of Endangered Wildlife in Canada assessed the black swift in 2015 and recommended it be listed as endangered based on steep declines over the last several decades. And then by May of 2019, the bird was placed on Schedule 1 of the Species at Risk Act. And once that happens, the recovery strategy is a requirement by the government under the Act, including IDing critical habitat where possible. And so the Canadian Wildlife Service is responsible for the completion of this. Although Parks Canada is working with the Canadian Wildlife Service during the completion of a recovery strategy and contributing our data towards defining critical habitat for the species. But, despite the density of breeding areas in Canada, very little is known about Canadian populations. There's been no banding or tagging of any birds in Canada. And population numbers are based largely on the breeding bird survey data, which uses the road transects to conduct the point counts, as some or many of you might know or participate in. And we've seen from black swift nesting habitat and foraging behavior that detecting those birds would be really difficult, especially given nesting habitat often occurs in quite remote areas. So they're a species of national conservation concern in the US, and the IUCN classifies them as vulnerable. Alberta has no conservation status, and they're blue listed or endangered in BC. So what are the main threats that black swifts are facing? For starters, they're a long-lived species, up to 16 years, with low reproductive rate, and food availability is likely a driver in population regulation. Meta-analysis have shown an overall decline in terrestrial insect abundance, and then in North America, the aerial insectivores, including the nightjars and swallows and swifts, are already experiencing long-term population declines. But it's not totally clear how big a role insect declines are playing in those population declines, and how the interaction of insect declines with other global patterns like climate change are also influencing aerial insectivore population demographics. So climate change is resulting in the decreasing snowpack, as I'm sure we've all observed over the last summer with those extended and extreme heat events, which can affect the timing and runoff and altering stream flow, which can both affect the microclimate at the nest site and insect availability and timing of insect blooms during the nesting season. And on wintering grounds in the Amazon, extensive forest burning and associated smoke may be impacting insect availability. So it's a likely, a combination of drivers influencing insect availability over the annual life cycle of the birds. So swifts are already limited by suitable nesting habitat based on those particular requirements. And with climate change, we're probably looking at less suitable habitat over time. So the last one is recreation impacts. So that is a threat that was considered to be negligible by the COSEWIC assessment. But, overall impacts from recreation are pretty poorly understood, although there is a growing body of evidence that indicates those recreation activities can alter habitat use. The pandemic has been an interesting experiment in providing us with an opportunity for some baseline studies in areas that typically have really dense tourist activity, and provided some insight into wildlife displacement that we haven't been able to tease apart before. In Johnston Canyon in Banff National Park, we saw a steep drop in visitation over the 18 months during COVID mitigations. So potential disturbance from recreation, shouldn't be minimized regardless of the little research that we have on direct measurements impacting swifts. And that's something we're really paying close attention to in Banff National Park, and particularly in Johnston Canyon. So some of the monitoring challenges, it's challenging to monitor a species that spends most of their time in the air at higher elevations. Monitoring nesting locations isn't much easier, as their nesting sites are in often hard to reach locations. Their nests are high, they're in dark places, and they spend a minimal amount of time at the nest. So locating and observing birds is extremely challenging. So some of our current knowledge gaps, until last year, we had only known of one nesting site in Banff National Park, and only a handful of sites combined across the national parks. And one of the biggest gaps has been understanding where in BC and Alberta birds are nesting. And until we know the locations of nesting colonies, we won't be able to monitor their activity over time. So that's one of the priorities. Thankfully, extensive effort is being invested in locating nests across Western Canada through combined efforts with Parks Canada and the Canadian Wildlife Service. So locating additional nest sites is going to give us an opportunity to monitor them, compare high human use sites with no or low human use sites, and then locate historic nests, which may give us a clue to what range contractions may already be occurring. Although timing of nesting events has been studied for quite some time in Colorado, there's really very little known about nesting phenology for black swifts in Canada. When are birds arriving and leaving nest sites seasonally? When are birds coming and going within a 24-hour period? Where do non-breeding subadults go in the breeding season? And where are Canadian birds migrating to? We assume they're migrating to the same place, but we don't know for sure. And are the same birds returning to the same nests and nesting sites each year? So, some DNA confirmation would be amazing. And how much area around nests should be considered critical habitat? So overall, black swifts are one of the least understood bird species in, overall, one of the least understood bird species, and particularly the Canadian populations are poorly studied. So this is a good point to segue into highlighting what we do know about black swifts in Banff National Park, and showcasing Johnston Canyon as our primary study site. So Johnston Canyon is a fantastic example of site fidelity over time. The colony's been active for at least 100 years, and likely much, much longer. The first black swift was actually discovered in 1909 in California, but Johnston Canyon was confirmed in 1919, which made it the first confirmed inland site in North America. So historic records in Johnston Canyon indicate that until the early 80s, 1982 in particular, the colony was relatively stable with a high count of 12 nests, active nests, after which that time numbers dropped steeply, and they fluctuate over time overall, but with only a mean of 2 nests for 37 years. So I am happy to report that the last 2 years we've had an increase in nesting activity. Last year we had 3 active nests, and those they all fledged. And then this last year we had 5 active nests, and those nestlings all fledged. And so having 5 nests, that was the first time since 2005 that we had had 5 active nests. And really the only reason we know some of these historical numbers in Johnston Canyon is thanks to Jason Rogers, who heads up the Banff Community Bird Walk and oversees the local eBird reporting, and also Jeff Holroyd, who is a now retired ornithologist with the Canadian Wildlife Service, who had collectively been monitoring black swifts in Johnston Canyon since the 70s. And Jason continues to collaborate with us and provide valuable input into the monitoring program. And so the way I started in 2015, I started the monitoring program when black swifts were being assessed by COSEWIC. And then at the same time, we had some additional railing and fencing being installed in the canyon. So it was, some of those nesting sites needed to be flagged, so to avoid disturbance to nesting birds. So I met with Jason and Jeff to identify several of those nesting sites in Johnston Canyon. And at that point they were marked, and then I've been monitoring them ever since. So Johnston Canyon is the longest data set that we have for nesting black swifts in Canada. It's quite a unique location where we can actually directly observe the nests in several spots. Places like Marble Canyon in Kootenay National Park and Moline Canyon in Jasper National Park have long-standing colonies as well, but those nests are not visible. So let's take a look at some of the imagery that we've collected over the last few years. So with an increase in monitoring frequency, we've been able to collect data on egg laying dates. So this is the first photograph we have of an egg. Aging chicks. And this is one of my favorite photos. In this photo, you can see the first flight feathers coming in on the chick. And then we've also been able to observe pre-fledging behavior in the chicks. In this photo from Amar, the chick is really close to fledging, like within a week, and it's exercising its wings. Once that bird fledges, it's not going to return to the nest and will begin its flight to South America. And the time frame between from egg laying to fledging is about 10 weeks or 2.5 months, which is a relatively long period for a small terrestrial bird. So let's look at some of the tools and technology that we're using to monitor swifts and conduct our inventories. So our preferred approach has been to minimize disturbance to swifts and still collect valuable data. Although banding and tagging birds would fill in a lot of data gaps for the species in Canada, so far the logistics and safety for birds and personnel for this research has been prohibitive. So this is quite an array of research tools we've either integrated already or in the process of testing, which includes the locating additional nesting sites, drone surveys, infrared cameras, remote cameras, temperature, humidity loggers, and diet analysis. So to start off with, our priority on locating additional nesting sites. Until last season, we only had 1 confirmed site in Banff National Park, and through our expanded survey efforts over the last couple of years, we were able to confirm a 2nd nesting site in a remote area in the south part of the park. So the process basically starts with identifying other waterfalls and canyons based on eBird observations, looking at Google Earth, the World Waterfall Database website, and speaking with other park staff who travel extensively in the park. In fact, we've had a lot of help from the aquatics team, who are regularly in the field working directly in our watersheds and know where many of those waterfalls and canyons are. So we start with conducting a habitat survey to establish a rating of habitat quality based on the characteristics I mentioned earlier. And then if they are suitable, we conduct what's called a dawn occupancy survey, which requires 2 surveyors to sit patiently watching a waterfall or a canyon feature for an hour and a half to detect adult swifts leaving the nest or leaving the waterfall or canyon feature, and that starts about a half hour before sunrise. We also scan rock faces for evidence of nest characteristics of black swifts and document them for activity in following years. And, it's inherently difficult to locate nests, which are, often well hidden, maybe under an overhang, or it's so dark to see any contrast. And yeah, so it's quite a challenge. So this is a good example here. This is an example of how well hidden black swifts can be. This was a rare sighting of a swift roosting beside a waterfall during the day, which I had never seen before, likely waiting for a shift change with the other adult who would have been incubating the egg at this time. So the bird was observed during the habitat survey, and it was a really good clue that swifts were active in the area. So we returned a week later for an occupancy survey, and we observed 5 birds leaving the canyon and confirmed this site is active. So this has been a really interesting and exciting application of research. So drone surveys. The last 2 winters, we took the opportunity to test the use of a drone to locate black swift nests while the birds are actually away on their wintering grounds. Drones had already been integrated into the visitor safety program, into the bison reintroduction program, and into our wildlife shop to safely conduct carcass site investigations. So it seemed like a really good opportunity to test its efficacy in locating nests. And we were really fortunate to already have some of the equipment and trained pilots. So in Johnston Canyon, although we already knew where some of the nests were based on historic data, we knew that there were likely other nests to locate. And no nest site locations were known for Marble Canyon prior to the drone flight last winter. So we tested the drone both in Johnston Canyon and Marble Canyon, and we're able to locate nests in both locations. Yeah, so that's been exciting. And so Johnston Canyon, Marble Canyon, and then as well as in our new site that we confirmed last year. So the value in locating nest locations is pretty huge. It helps refine occupancy surveys in the summer by knowing where to position researchers to improve detection of the birds, which is already quite difficult. And it also fills in important critical habitat data and helps with the process of defining that critical habitat. It may also help us identify where recreation activities like ice climbing and canyoneering, which is quite popular in Jasper, could be putting nests at risk, and work with these user groups to avoid disturbance of nests. So how we went about this, we focused on sections we couldn't access or see in Johnston Canyon and historically reported areas. And in Marble Canyon, we flew all canyon segments with suitable flying conditions and were able to stage from each of the 7 bridges in Marble Canyon. Pockets, ledges, and niches with yellow, green, or white wash underneath were photographed, as well as any mossy nests. And so far in each of the 3 sites we tested the drone, we've located 3 black swift nests in Johnston Canyon, about 6 in Marble Canyon, and then 2 or 3 in our newly located nesting site in the south part of the park. So this is kind of what it looks like after we've analyzed the photos. The contrast and reflection from the snow made it easier to identify the green hues in and below the nests. And although even with the drone's capability, flying conditions could be really challenging, and some sections couldn't be flown at all, or some of the imagery wasn't sufficient to confirm a nest and might require additional flights. So this gives you an idea of the green staining that accumulates from the urates over time around a nest, and how dark and obscured a nest ledge can be. As well, there are often roosts nearby, nest pockets or ledges, as the nest itself may not even have room for 2 adults and a chick as the nesting season progresses, or one adult may just roost nearby waiting for an incubation switch. So I've got a little video for you here. So this is a clip of drone footage in Johnston Canyon. So taking video footage was critical and was especially helpful in providing scale and context to the photographs. It was easy to get quite disoriented when you're looking through thousands of photos and not having a sense of how far off they were from the creek bed or what the orientation was while you were flying the canyon. And then, you can also see there's quite a bit of snow accumulated here. So although the snow provides some good reflection and contrast, we're thinking that some sites might actually be better to fly sort of late fall before the snow arrives, but after the black swifts have left. So I think that'll be quite site specific. So we were really fortunate to have the resources and support to test this technology, and we were the first researchers to implement this tool in black swift research. We worked quite collaboratively with a local drone company to address the technical flying requirements unique to waterfalls and canyons, select the best equipment, understand the regulations and permitting processes, logistical considerations, as well as black swift ecology, combined with all those other factors. And then we developed some standardized guidelines to share with other parks and black swift researchers across North America, as well as those looking to implement a similar approach in other wildlife research. So this past winter, both Waterton, Jasper, Mount Revelstoke Glacier have conducted a number of drone flights with some success as well. So moving on to the infrared camera. So as you've learned so far in this presentation, black swifts are really hard to detect due to their cryptic nesting sites and aerial lifestyle. So even if we know where nests are, or maybe it still could be difficult to determine if there's actually a bird attending the nest or a chick on the nest. And the nest could be partially obscured or too dark to see if an already dark bird is sitting on the nest. So we were fortunate enough to, again, already have some of that equipment. We had an infrared camera in our office for use in wildlife operations, so we could easily test its application in swift monitoring. I took it out last year for the first time in Johnston Canyon in the summer to see if a black swift adult and later a chick would give enough of a heat signature to show up on the camera. So, Johnston Canyon was the ideal location because we already knew where a lot of those nest sites were and we knew they were active. So both adults and chicks were identified at a distance of about 15 meters. And then as well, I was able to see a Pacific wren, quite a bit smaller and on a nest in Johnston Canyon at about 20 meters distance. I also tried it at a site in Kootenay National Park where we knew where the nest was, but we weren't sure if it was active. It was just so dark in there, and the nest, was just high enough that you could only see the edge of it. But with the infrared camera, I was able to confirm that there was a chick, in fact, on the nest, which was really cool. I tested it too in Marble Canyon during a morning occupancy survey. So I did detect birds in flight, but it was really difficult to observe the birds actually leaving the canyon. It's a long canyon with multiple entry points and exit points, and birds just come out so quickly. So we aren't sure of its efficacy in canyon occupancy surveys. So we're focusing more on the waterfall sites. And in this past 2021 season, we implemented paired surveys with the FLIR and naked eye observations at the waterfall sites across our park and some of the other mountain parks. So the camera we used has a really good field of view, so you could, best capture the waterfall itself and then the habitat adjacent to it. And last winter, we contracted somebody to develop a script using image classification software so that, it could assist us with analyzing all those hours of occupancy survey footage. And that software will expedite the analysis to locate and mark any imagery of movement of a bird in the recording. And then we can compare the results of that with the observer surveys. So I've got another little video clip here for you. So a couple short clips in here of an active black swift nest. In the first clip you'll see the heat signature of a black swift on its nest with a zoomed inset at the top of the screen. And this was taken during a dawn occupancy survey at Johnston Canyon. So you'll first see the swift adult depart and adults from nearby nests circling and interacting when they first depart for the day. And then the remaining adult leaves the nest in the frame. And then lastly, an adult is seen returning to the nest. And without the use of that FLIR, it would have been more difficult to get an accurate count of birds circling and then catch the moment the bird leaves the nest. And, you know, this is all happening in a dark canyon at dawn in very low light conditions. And, you know, the movement happens quite quickly and could easily be missed. So our next tool is remote cameras. So I set up 2 cameras at different locations in 2020 and again in 2021. And this past season, I was able to get the camera actually set up before the birds arrived in the spring. It was quite difficult to find suitable locations to capture the right angle at the nest, you know, a distance close enough to capture activity and objects to actually attach the camera to. I initially tried to set it up in trigger mode, but the distance was just too great and the birds moved too quickly. So I had to program it to take photos every hour and video as well. And, you know, this is just speaks to the challenges. Although the first camera I set up was, you know, pretty unnoticeable, it wasn't perfect. And there were a number of incidents where people bumped the camera out of curiosity. So I'm working on getting a permanent security case welded up there so that I don't risk losing any of that camera data. So the camera I used was the Reconyx camera model, which is the full covert camera that uses a no glow infrared for nighttime images with no white light flash. So results from that, using the camera this year, I was able to capture the hour the birds first returned to the nest after arriving from migration, narrow down the timing of a chick fledging from the nest to within an hour, as well as collecting some data on timing of shift changes between both adults and both adults brooding the egg, daily arrival and departure times of both adults. And, you know, there's no other locations in Canada where we're able to collect this level of phenological data so far. So we're looking to also set up another camera at the new site we located last year. And this would give us an opportunity to compare the phenology at the 2 sites in the park, as well as maybe tease apart any differences in nest attendance between a site with high human use and one with no visitation at all. So here's a few images. They're not very close, but still close enough to collect the data that we're looking for. So here's a couple photos of birds returning to the nest at dusk, usually around 10 or 11 o'clock every night. The nest ledge or pocket is pretty tight for the 2 adults and a chick. And then this photo is taken later in the season when the chick is, you know, virtually within days of fledging from the nest. You know, at this point, the nestling is going to be as big or even heavier than the adults. Next tool is the data logger or the temperature humidity sensors. So I'm quite excited about these ones. So last year I was able to coordinate with our visitor safety team to access 3 of the nests in Johnston Canyon and place tiny temperature and humidity sensors. So they're about the size of a like a little watch battery in the nest pocket, so we could measure what kind of temperature and humidity variation is occurring at the nests. And we know that having a stable microclimate at nest sites is important in site selection, which may play a role in keeping that metabolic rate low in the chick while the adults are on those long foraging flights. So this research has been done in one study in 2010, where temp and humidity were measured at sites in Colorado, New Mexico, and California. And there they found there was very little variation in the temperature, and the humidity remained quite high. But with climate change, we may see, you know, a drier climate and so a reduction in the humidity and then, you know, an increase in temperature over time. And nest sites that already occur at the edge of their range in drier locations like Johnston Canyon will likely be at greater risk of becoming unsuitable over time. Collecting this type of data will contribute to our understanding of any range contractions. And so actually a few weeks ago, I was able to retrieve those 3 loggers that I deployed last year and place 3 more out in the canyon. And from looking at the data so far, I was able to see that the one nest that's the closest to the catwalk or the boardwalk, where thousands of people walk by every day, also had the most stable microclimate of the 3 nests that I sampled. And it was also the furthest from a waterfall, so I certainly wasn't expecting it to be as consistent as it was. So these couple photos here give you an idea of the logistical challenges to even access the nests and reach them, and why this is such a successful nesting strategy to avoid predation. And to share one last piece of research, we're looking to pilot for next year, and that's conducting a diet analysis of nesting black swifts in Johnston Canyon. There are a couple locations in the canyon where there's an accumulation of adult feces and potentially some nestling fecal sacs that can be collected, and hopefully meta barcoding analysis conducted. So there is one older study that was conducted on diet analysis in California, where swifts were actually captured and the food boluses were analyzed and size of prey measured. And then there was also one study, a short study done in Johnston Canyon by Jeff Holleride that I mentioned earlier, who analyzed fecal sacs or droppings. So these studies indicated that the dominant prey type fed to the nestling, particularly in July and August, were the winged ants. And so the winged ants are really considered the ideal food source due to their exceptionally high fat content. And these blooms of the winged ants tend to be, super abundant for short windows later in the summer, and making them, such an ephemeral and patchy food source that may require longer flights and higher elevation flights to access, especially later in the summer. So black swifts may have adapted their breeding behavior around the timing and dispersal of this high fat prey source, and then investing, just in one slow developing chick over a longer and later breeding period. So we're pretty curious to see how results from the 82-83 study in Johnston Canyon would compare with samples taken 30 years later, and if that proportion of flying ants in the diet is changing at all. And then we're just hopeful that the DNA quality would be sufficient from collected feces to both identify the prey type, and then, if we're lucky, maybe sufficient DNA to identify individual adults and chicks from each nest. So here's a little video for you. So as the chick gets older, I mentioned the time between provisioning becomes progressively longer, as adults are spending more time foraging before returning to the nest, which may be to ensure those adults can put on sufficient weight for the long migration to the Amazon. So I edited out most of the video, but even in this short clip, you can see how persistent the chick is in asking to be fed. And we've never had this kind of footage till this year. So now that I've provided quite a comprehensive overview of the inventory and monitoring efforts we're implementing, I wanted to just wrap up the presentation by highlighting how this effort is being converted to action on the ground. So we've steadily increased our monitoring efforts over the last 6+ years and amassed some valuable data. As well, as a result of all this data that we've collected, we now have such a greater capacity to implement active management measures in the park, including, seasonal trail restrictions, and integrate a more adaptive management approach, which means being responsive as we learn more. So this is definitely not a standalone process. We're working quite collaboratively. All the mountain national parks, some of the provincial parks, researchers, and the Canadian Wildlife Service to standardize our monitoring, share results, challenges, provide feedback, and discuss how we can implement more consistent approaches to conservation measures. So this also includes developing those relationships with user groups like the ice climbers and canyoneering community. And thankfully, we've been able to secure funding to support some of these initiatives that require quite a bit of resource and equipment to undertake. So we'll just take a look here at Johnston Canyon as an example of managing activity in a known black swift nesting colony. We have several trail counters to collect user data, and that trail counter data indicates just under 1 million visitors to Johnston Canyon in 2019. And those numbers may actually be low due to the limitations of counters to enumerate clusters of people. And then during the pandemic, numbers dropped to about 10% of 2019 numbers due to some of the COVID mitigations, and access to Johnston Canyon was more difficult. And now we're returning to pre-pandemic levels, although we haven't reviewed the trail counter data for 2021. So some of the most iconic photos that come from Banff National Park include several waterfalls, and particularly a spot known as the Secret Cave location, which is no longer a secret at all. And so social media has really driven this frenetic push to post photos from this location. But overall, the visitation trends just keep increasing, including in the shoulder seasons. I was just up at Johnston Canyon deploying those data loggers on Remembrance Day, and pretty much it seemed as busy as a day in May. So we've also got other activities going on at the canyon, which includes ice climbing at the upper falls and then ongoing maintenance work in the canyon. So in 2018, we started restricting access to that secret cave I mentioned between May and November, and that's expanded to a full off-trail restriction in 2019. And this means visitors can't access the secret cave at all during that time, or go off trail. So it's just requiring people to stay on the trail at all times. And we're just really looking to support a buffer between the nesting birds and the public where possible. So our visitor experience team has started providing interpretive staff at Johnston Canyon to answer questions about the restrictions and some background on black swift ecology. There's very, very clear signage, railing, and cable to help with wayfinding and guiding visitors where it's appropriate to hike and view the canyon and falls. We've got online messaging, which provides information for all of our species at risk and any updates. Any maintenance activities that are going on in the canyon must happen outside of the nesting window. And then we also work with visitor safety and law enforcement, so that when urgent or emergency situations arise, that cross-function communication is already there, and they're aware of the nests and any actions that might disturb nests. Example of this last summer, there was a search up in Johnston Canyon with a missing person. Very few details on the missing individual, so RCMP were looking to use a drone to search the canyon, which in the end was averted, but thankfully we were consulted in advance so that we could have provided guidance about the appropriate use and timing of that tool. Another example was in Marble Canyon, where last summer there was an unfortunate incident and visitor safety had to fly in with a helicopter to rescue an individual, and were hovering directly over the canyon. And obviously rescue work is essential, but I was at least able to discuss locations with visitor safety team and then collect information on where they were and what time of day the rescue occurred to sort of ascertain that level of risk to nesting birds. And in Johnston Canyon, we've had incredible support from our law enforcement branch, who consistently have been increasing their surveillance efforts and issuing fines for violators that continue to enter the closed area, unfortunately. So given how far up that canyon the secret cave is, and how far they have to hike and how busy they are in the summer, this is pretty impressive. So ultimately, I guess essentially we're looking to build some public support for these conservation measures for black swifts and all of our species at risk. Really, we're just aiming to foster that stewardship and help visitors understand and care. We've had quite a bit of media attention in the last year with local, regional, radio, print, and TV, which serves to bolster that support as well. Yeah, and to be honest, it's clear that many of these threats the species faces are driven globally, and they're really complex, but the cumulative smaller actions we're trying to take work towards building support for the larger ones. So it's important that we don't lose sight of that. And then as we collect more robust data on the life history and status of the species in the park, we can, like I mentioned before, we can continue to adapt those management strategies to support them and continue to collaborate. And I think one of the biggest lessons that I've learned, and that I think we're all learning, is that the key to this is collaboration. So I think that's the end of my presentation, and I'm happy to open it up to any questions or comments.